Hello everyone. In last video, we discussed how to create NumPy array object by using different types of function. Now, in this video, I'm going to explain what are the attributes of ND array object and what is the meaning of vectorize operation we can perform on ND array object. So first of all, open command prompt, type anaconda, open anaconda prompt as usual. Then go to the current working directory. Now, as usual, I'm using the same current working directory is equals to which one C colon on C colon code folder is present. Now here, change the current working directory. So just write down cd slash change directory. Then write down cd, the name of the folder is equals to code, press enter button. Now type the command Jupyter notebook. Now that will open Jupyter notebook inside which one browser. Now I'm going to create a new notepad, notebook actually, not notepad. I'm going to create one notebook inside which I'm going to explain what are the attributes of ND array object and what are the vectorized operations we can perform on ND array object. Okay, now first of all, create the new Jupyter notebook. Now here, first line, write down which one, import numpy as np. That as usual, you have to write down this one. So write down here, import numpy as np. Okay, and press shift enter button. Now, first of all, I want to explain attributes of numpy ND array object. For this purpose, I'm going to create one array that is two-dimensional array. For example, arr is equals to np dot, the name of the function is equals to, I'm going to use that is equals to array. Inside this function, I'm going to pass a nested list. So just pass here nested list. Here write down the first row 11, 12, 13. You can give any number, doesn't matter. Just for understanding purpose, I'm taking this simple array. So control V, then control V, change the value here, that is equals to 14, then 15, then 16, 17, 18, 19. Okay, so you can cross check really it is working or not. Just press shift enter. Now check out this array is created. Now you want to check attributes of this array. So how to check the attributes of this array? So first of all, a very simple attribute that is equals to ndim. So this attribute gives the number of dimensions for your array. So when I press shift enter, check out, it is showing number of dimensions is equals to 2 dimension, because this is 2-dimensional array. So this attribute gives the number of dimension. Then another attribute that is equals to which one, shape, for example. So what is the shape of this array? Check out this one. The shape of the array is equals to which one, 3 by 3, means what, 3 rows and which one, 3 columns. Now suppose you want to calculate the shape of array, then simply call the attribute. Now one more point you have to remember here, while calling the attributes, do not give the opening closing bracket. Opening closing bracket indicate that is the function. Okay, so just write down what, without opening closing bracket, that act as an attribute. Now suppose you want to calculate a number of items present inside your array, then simply write down arr dot, the name of the attribute is equals to which one, size attribute, press shift enter. Now check out, it is showing number of items present inside your array is equals to which one, 9 items. So actually these are very simple attributes we can use for your project while doing machine learning or data science project. Now suppose you want to calculate the size of which one item present inside your numpy array. For example, just write down arr dot, the name of the attribute is equals to item size. Okay, item size. So when I press shift enter, check out each item present inside this numpy array occupy how much memory, that is equals to which one, 4 bytes of memory. But before that, again you can check what is the data type of each and every item. So you can check data type of each and every item by using which one, d type attribute. So check out, when I write arr dot d type, so that indicate the data type of each and every item present inside your numpy array is equals to which one, int 32. Now while creating here, object, you can specify data type. Data type is equals to, you can write here d type, comma d type is equals to what, float, for example. Okay, now execute this one, check out. Now check out, number of dimensions same, shape is also same. Now number of items present inside that array is also same. But check out here, now item size is equals to which one, 8 bytes, means one float required how much memory, 8 bytes of memory. And check out the data type. Now data type is equals to which one, float 64. So these are very common attributes. Again, now suppose you want to calculate how much memory, total memory allocated for this numpy array. Now check out here, one item required 8 bytes of memory. Then total number of elements present inside which one numpy array are 9. So 9 multiplied by 8. So check out here, that should be displayed 72 bytes. So write down here arr dot n byte and shift enter. So check out number of bytes allocated to that numpy array is equals to which one, 72 bytes. So in short, you can check these common attributes of which one, that may be one dimensional array or which one two dimensional array, doesn't matter. Okay, now I want to calculate or perform simple operation on which one numpy array. For example, check out here, I'm going to perform operation, basic operation. So convert this tag cell to the markdown cell. So just press escape and press M button. It is converted into markdown cell. Give the heading here, basic operation. Basic operation. Okay. Now, what is the basic operation I want to perform? Suppose I want to create one array. Check out here, one dimensional array. So before that, take one data. Data is equals to, I'm going to use the range function. This is the Python basic function. So 1 comma 100. So what is the meaning of this one? That will select all the values between what range 1 to 100. Okay, so you can typecast it into list also. Just write down list, control V. Now check out here, it will display how many values present here. It consists of which one, 1 to 100, 1 to what, 99, not 100, 1 to 99 value present inside which one, data variable. Okay, now using this data variable, I'm going to create array. Arr is equals to np dot array, in bracket, write down the data. Now you can print the array. Check out here, now it is showing all the values like 1 to which one, 99. So these number of value present inside which one, this array. What I want to do, I want to add two value to each and every item present inside which one, array. So how to do this one? Simply put down for loop for I in range, in bracket, range in bracket, starting index is equals to 0. Starting index of this one is 0, 1, 2, in this manner, comma, go to the length of what, length of array. Okay, so here I'm going to print, for understanding purpose, I'm going to print each and every item present inside the array, just like a normal syntax here. Check out Python syntax, arr in bracket index. Now when I execute this one, check out, it will display all the value present inside which one, your array. But what I want to do, I want to add two value to each and every item present inside which one, array. For this purpose, create empty array. Okay, so how to create the empty array? To hold the result, create the empty array. So just write down np dot empty, empty like, empty like, in bracket arr. So what is the meaning of empty like? This function will create a exactly similar size array like arr. Okay, so how many items present inside arr? 1 to 99, total 99 elements present there. So it will create the array with the 99 element but uninitialized. What I want to do, I want to store the result inside this array. So come back here, arr1, arr1 of I is equals to arr plus what, 2. Okay, and that's it. Go to the next cell, go to the next cell and print here arr1. Now again execute this cell, check out here, execute this cell. Now there is a error actually. So what is the error? We forgot to give here a square bracket, actually error of I. So again execute this one, check out, it is executed properly. Now execute this cell, check out this one, 3 4 5 6 7 8 9 means what, two value added to what, each and every element. You can change this one, add the 10 value to each and every element. So check out, 10 value added to each one, each and every element. Means in short, what I want to perform, add 10 value or particular scalar value to each and every item present inside which one, array. Now it is actually little bit slow. So you want to calculate how much time period this particular operation is taking. So what you can do, you can simply write down a magic command that is called which one, time it, and execute this one. So check out, it will display, this magic command will display how much time period, total time period. Check out, total time period is equals to which one, 55 microsecond. Okay, and here again check out here, 1.68 microsecond per loop. Okay, so that is the total time period required for the execution of which one, this code. Now is there any way same operation can be performed by using which one, small amount of a small amount of time? So check out this one, this slowness of loop can be avoided by using which one, vectorization. So what is the exactly meaning of vectorization? The vectorization is a powerful ability to perform operation on entire array rather than their individual item. So that is the description about which one, vectorization. Now, how to implement the vectorization inside Python? Vectorization can be implemented by using universal function. Now, what is the purpose of the universal function? Universal function directly apply on all array instead of applying operation on which one, individual item present inside which one, array. For example, check out, same operation I can perform within a single line. Check out np, that is a numpy array, then call the add function, in bracket write down the array name is equals to arr comma 10. Okay, now check out, meaning is same. What is the meaning here? Again write down here arr, suppose 2 here is equals to, result is stored inside arr2, and print the arr2. Okay, check out here, I'm going to execute this one and check out this one. Now check out output of what, both operation is same, but this is what, normal for loop. By using normal for loop we perform that addition operation. Here I'm using vectorization or universal function to perform which one, operation. Now what is the advantage of this vectorization operation or universal operation? So you can copy this command and paste here. Okay, now check out, execute this one. Now when I execute this one, it will display how much time your vectorize function take to complete that operation. So check out here difference, it take 853 nanosecond. Okay, and here it is taking which one, 55 microsecond. Means this loop is taking very much less time as compared to which one, normal for loop. So these are called which one, vectorize operation or universal function. So remember, again I'm going to repeat this one, vectorization is a powerful ability to perform operation on entire array rather than individual item of array. Okay, and vectorization can be implemented by universal function. Okay, so this is universal function, add is a universal function. Now take out another example, suppose np dot, you can use any function like subtract function, subtract, np dot subtract in bracket arr comma, suppose subtract 2. Check out, 2 value is subtracted for which, from which one, each and every item. Again write down np dot, suppose multiply, you want to multiply something, arr comma, suppose 5. Now each item is multiplied by 5. Then suppose you want to perform division operation, np dot divide, then in bracket you can write array name comma, divide each and every item by some value, for example 4 value. So check out that each and every item divided by 4. Then suppose you want to perform positive value into negative value, means complete array converted into negative value. Then write down np dot negative in bracket ARR, press shift enter, check out each and every value converted into negative. Means what is the point I want to explain? These are called vectorization function. So throughout the numpy array, I'm going to use vectorization function because it will speed up the program execution. Now you can compare these two lines. Check out here. When I execute this code, output is same. Output is same, means output of this and output of this is same. Only difference is that it required more time for the execution, and it required small amount of time for the execution. Again, it required more lines, number of lines. Check out 1 2 3, suppose 3 4 for loop, total 5 lines of code. Here 1 lines of code. Means writing code is not very important, but execution time period is very less when we use which one, vectorization function. So a lot of vectorization function available inside which one, numpy array. So again, I'm going to repeat the definition of vectorization function. Vectorization is powerful ability to perform operation on entire array rather than individual item of the array, and vectorization implemented in NumPy by using which one, universal function. So this is the total description about which one, attributes of ND array object, and vectorization. What is the vectorization inside which one, NumPy array?